Hi everyone, I'm Chui Chua, Analyst for Big Data, Analytics and Cognitive Systems for IDC in Asia Pacific. Welcome to today's webinar on Making Buildings Smart, hosted and sponsored by Intel. We're also very fortunate today to have on board a guest speaker, Mr. Isaac Jacob, VP of Fusionex Enterprise Practice Group. And our agenda today is to give you the latest trends and insights on putting the smart in smart buildings and highlight the opportunities for you in this fast-growing market. As more people move to urban areas, cities face ever more economic and environmental challenges, including resource constraints, economic restructuring, aging populations, and pressures on public finances. In their efforts to accommodate growing urban populations and the accompanying challenges, governments can use modern information and communication technologies to create smart cities and smart buildings that improve the quality and interactivity of urban services while reducing costs and ensuring sustainability. Today's cutting-edge IOT, Internet of Things solutions, enable businesses and other institutions to make better data-driven decisions for smarter buildings. By overlaying an IT network, connecting all traditional unconnected equipment, and applying automated analytics and controls, building owners and managers can significantly reduce their building's energy waste and cut costs. Buildings are generally responsible for almost 2/3 of overall electrical energy consumption in a city. That represents a major financial and environmental impact. For instance, lighting control systems, thermostats, sensors, and alarms, all connected to the IoT, can automatically adjust building settings according to real-time usage patterns, leading to energy savings, improved air quality, and increased overall efficiency. In addition to energy saving, as a result, smart buildings improve the indoor experience for occupants. For example, on a sunny day, windows can automatically darken themselves, and when sensors detect an empty room, the air conditioning automatically turns off so that the buildings can employ this type of energy-saving technology to improve occupants' quality of life, workers' productivity, and students' chances for academic success. Other areas of smart technology applications include access and security, where intelligent video analytics and access control systems are gaining widespread adoption. For building management, we have seen centralized performance data and analytical insights reducing power consumption by 17% on average. Current practices tend to focus on capital expenditure first, replacing old equipment with new. But this approach is often premature. Many times, the better solution is to evaluate what already exists, improve its efficiency, and use the savings to invest in capital improvements. Building managers can realize this significant energy savings purely from operational measures. In short, using the third platform technology of analytics, big data, cloud, and mobility, any building can evolve and innovate into an intelligent smart building. How to make a building smart? So to make a building smart, there are three key factors: optimize, integration, and communications. Optimization is about cost savings through the efficient consumption of resources, and integration is about aggregating internal and external data throughput throughout the building to obtain insights from the entire building ecosystem, thus giving us the ability to optimize. Lastly, transparent communication helps occupants and building managers obtain activity insights so as to create awareness and improve services and experiences. To get all these three ingredients requires the third platform technologies. The value delivered by smart building capabilities is enabled fundamentally by integrating systems of sensors, connectivity, and analytics of sensor data. The capabilities of IDC's third platform, which includes big data, analytics, cloud, and mobility, and the innovations accelerators, in particular, security and cognitive systems such as AI and IoT, all form a critical part of how building owners need to bring together technology capabilities into an integrated smart building IT environment. Analytics are being used to optimize building operations based on data sourced from systems across the building. So for example, dashboards, visualization, cognitive or AI processing, and predictive analytics are increasingly becoming competitive differentiators for smart building owners and IT service providers. Enabling cloud services for smart building data management is also a growing trend. Cloud Cloud platforms enable easier integration of data extracted from systems across the building. And mobility allows for wireless connectivity between devices and sensors, enabling legacy infrastructure to be enhanced into smart systems. And it is through such collaborative capabilities that enables interaction between facility managers, suppliers, for effective coordination of building management work. So here's a chart from Intel to illustrate how the third platform technology of cloud, mobility, and big data analytics works as a smart architecture platform. The legacy systems are supplemented and enhanced with intelligent gateways and sensors that collate the data, typically via wireless protocols. Such data are typically in different formats and unstructured nature, requiring the big data analytics to integrate and extract insights from this data. The compute power and availability of applications and APIs in the cloud is a natural fit for smart building data, delivering in real-time insights without building owners having to invest in on-premise infrastructures, and in short, giving the ability to quickly extract business value from the building data. Energy management forms the basis of most smart building strategies in the market today. But as smart building technologies get more advanced, they will evolve from being pure facilitators of energy management to becoming a dynamic ecosystem that takes user experience to the next level. The perceived future will be about creating an intelligent ecosystem where experience of the user will be managed and delivered by the capabilities of the building. Such a smart building ecosystem can include 5 key areas. Taking wearables as an example, in smart assets, where today we are seeing solutions based on smart glasses and wearable camera solutions, helping maintenance workers find out where the building issues are as they make their rounds. A recent example had augmented reality capabilities for maintenance workers to quickly identify infrastructure data as such data are overlaid onto their smart visual glasses. With smart people, occupants can be tracked in real time to ensure proper allocation or automated actions of resources in the building, in addition to ensuring smart access controls and security. One of the upcoming trends is the usage of digital signage. It is used in smart building environments to inform occupants of real-time updates. For example, in a retail environment, digital signage can deliver real-time information to lunch crowds on which eatery has a promotion or availability of seats and tables. And for smart parking, we have seen use cases where digital signage is able to deliver real-time information to drivers to find empty parking spots or traffic updates around multiple exits from the parking lot. Let's dive into what are the growth areas in smart buildings. We can categorize them into 4 areas. Growth in the economy, where new developments are constructed with the next generation technology as demand increases for better and high-tech commercial and residential space. The green movement is also here to stay, and new construction typically are defined with environmentally friendly requirements. Even new towns and cities are being developed with smart technologies to be sustainable. The advances in technology allows existing buildings to be quickly fitted with intelligent equipment without having to gut the existing infrastructure. In addition to new edge processing technology, such as intelligent gateways and sensors, we are seeing the barriers of entry drop drastically with each new iteration of technology innovation. Last but not least, the quality of life has been improving since the start of the first industrial revolution. And it is through smart building technology that the quality of life elevates to the next level, simply because people spend the majority of their time either working or residing in a building. Let's go a little into the insights and trends of the smart building market. Asia Pacific is the 3rd largest market for smart buildings in the world, and is expected to grow at a compound annual growth rate of 15.7% from 2015 to 2020. This anticipated growth in the smart building market can be attributed to the economic growth, increasing household incomes, and environmental awareness within the APEJ countries. A critical enabler of this growth is the government program and policies supporting smart cities, sustainability, and tax relief for new building investments and sustainable investments. These schemes incentivize and accelerate the growth in smart building investments. Smart building market has a diverse vendor ecosystem. There are no off-the-shelf solutions per se, Rather, there is a mix of solution components from different vendors that require integration to create an end-to-end solution in which each building environment is made up of a large mix of different IT and operational vendors. There is a considerable innovation coming from newer vendors that provide platform-based offerings utilizing cloud, analytics, and IoT in particular. From a technology standpoint, IoT and third platform capabilities will be the foundation of the smart buildings of the future. Smart building investments are made in the Asia-Pacific region are currently focused on solutions that are typically delivering cost savings through the energy efficiency and management initiatives. Looking to the future, ITC expects that the investment priorities will extend to incorporate greater sustainability and create intelligent buildings that transform user experience through capabilities embedded in its infrastructure. Let's run through a couple of examples of smart buildings, starting with visitors. Visitors to a building are often the most confused and lost group upon arrival. And car parks are often large, and there are restrictions on where visitors are able to park. So utilizing historical data on parking trends, visitors can be guided to available lots, or in the event that there are no free lots, to areas where someone is likely to move. Also, there can be dynamic allocation of public or reserved lots that can be achieved with adaptive cognitive or AI solutions. And most of us work in an office building, and one of the biggest challenges is meeting room management, which gets worse, of course, in larger enterprises. In a smart building, there's automatic detection of occupancy of rooms, which automatically updates the room status, whether it's free or occupied, and also freeing up room bookings if no one is detected after a certain time period. As such, better utilization of meeting rooms and room hogging behavior can be averted. And in addition to the above example, we are often familiar with the issues of temperatures in the office. So a HVAC system can be extremely tough to measure and to be balanced within an office. So dynamic HVAC and lighting based on the number of warm bodies is an example of edge intelligence that seeks to solve this common problem. So with respect to operating a smart building, for operators and owners of buildings, the main sources of data points are lighting, HVAC, and plug loads. Using this data, the analytics can improve efficiency of various facilities because often the disparate systems are used to control HVAC, lighting, lifts, and etc. As such, a consolidated interface would help improve the operational efficiency of the entire building in a way such that they can provide equipment monitoring, fault reporting, and of course, continuous monitoring of equipment values. And so they can optimize scheduling based on the equipment performance readings rather than routine schedule, in addition to triggering of maintenance workflow and spare parts ordering. Last but not least, there's also the benchmark of smart building analytics, allowing facility management to measure standards of service against internal, citywide, and nationwide KPI. To be able to support such comparative measures against multiple assets owned by the same entity allows for resources to be optimized and the ability to control power consumption, leading to savings on energy and reduced carbon emissions. I also want to talk a little bit about what smart buildings, what they can see, which is basically IVA, which is short for Intelligent Video Analytics. So we have individual tracking, which is analysis of travel patterns, very useful in identifying known suspects in public areas. And there's also crowd identification. Think of it as an early warning system for crowd gathering to avoid escalation in a situation. Example, a sudden crowd dispersion may mean something negative might have happened. It could also include sentiment analysis of individuals based on body language and facial expression. And in the event detection use case, we can look into use cases of trespassing to restricted areas or where accidents and emergency services needs to be activated. The other areas that use cases for intelligent video analytics include building exterior monitoring and also left remove items, so to identify potentially suspect items that are left in a location by someone suspicious. And of course, we also have activity detection, which is in the sense of loitering for an extended period of time or illegal parking at a drop-off pickup point. Smart buildings. What do they sense? In summary, we can break it down to 6 areas where smart building gains insights into their sensors. the ability to have 24/7 monitoring using intelligent video analytics, which was just mentioned, the ability to track real-time occupancy, the ability to track real-time parking availability. Fourth, the integration of external data such as weather and traffic. Fifth, the prediction and forecasting of inbound traffic. And lastly, which is the most common area, the delivery of better energy consumption. In short, smart buildings will become smarter with better and faster insights due to edge computing. On-premise servers will not be removed from the IT landscape even with the growing adoption of cloud. Instead, its role will evolve from an endpoint of computing to an intermediate view at the edge, which is the point of data collection. The way I would summarize it is the edge devices provide a local view, the on-premise systems or servers provide a regional view, and the cloud provides a global view. So the ideal location of an on-premise server is to be as close to the IoT gateways as possible so that which connects to all the various devices, thus reducing the network traffic requirement and provide faster response time. With immediate insights, local decisions can be made quickly to address potential issues or to improve operations such as predictive maintenance. And with better efficiencies, operation costs will drop. So let's dive into a little bit about the next generation edge technology with a reference to smart buildings. The next generation of edge technology for smart buildings is already here. System on a chip, such as Intel's Quark, can be easily integrated into smart edge devices to provide low-power computing and processing of data. Intel recently announced the availability of Joe Module, a Linux system on a module, which is also known as SOM, designed to help inventors and IoT developers create and innovate faster. This SOM provides high computational power, memory, and storage. And unlike many IoT hardware platforms, it actually features graphics and video capabilities. The onboard system allows for on-chip graphics for a 4K video display and also includes multiple camera connectors for intelligent video analytics. Such a system on a module allows for quick upgrades of existing embedded systems. Now, with real-time streaming data comes the need for fast flash-based storage at the edge. Intel's latest 3D NAND SSD family of products, such as the Intel SSD E5420 series, delivers endurance and power efficiency for the demands of IoT solutions and embedded applications. And very importantly to most organizations, this storage solutions offers built-in security through AES 256-bit self-encryption to help protect the data that is being collected. This series of storage are perfectly suited for IoT edge devices due to a small form factor, which is the gumstick size of M.2 form factor. Intelligent video analytics is also rapidly evolving. A good example is Intel's RealSense camera, which fits remarkable technology into a very small package, and an infrared laser projector that allows the cameras to see, just like the human eye, to sense depth and track human motion. It allows delivery of sight to analytics and providing the intelligence of smart buildings. Applications of IVA is unlimited, such as visual data can be used for all sorts of applications from facial recognition to footfall predictions. So, success stories so far with smart buildings. Savings are largely measured in terms of energy savings and carbon emissions. The intangibles such as the ease of use and experience is something we can all relate to instead. Even for owner and facilities perspective of the ease of experience, it's really, really important. Here are some of the real-world examples of the proof of value in smart building systems. AT&T's smart lighting system has resulted in $8 million in savings. And as you can see, there's actually energy savings of between 5%, 8% to 50% from the two other use cases. So what's in it in the future for smart buildings? Look at the future of smart buildings from three main personas: tenant, visitor, and owner, or the facilities department. As the building incorporates more technology, it will increase in having the tenants getting more comfortable and customized experience. The visitors will be able to have a much more smoother experience when entering buildings, such as in parking their cars, getting their access card, getting access to the place they need to be at. And owners will have lesser worries over service level agreements, suppliers, and equipment operations. In the yesterdays, scenario era. We have automated buildings where typically the control systems are being automated. They're very static, and most of them are manually tuned and very intensively requires intensive engineering skill sets, mostly CAPEX intensive and multi-year ROI. In today's environment, we're looking at building analytics with online data collection at the edge storage and display, providing historical analytics, usage trends, and benchmarking. The ROIs are dependent on people or capital, with real-time operations that are not being affected. So in tomorrow's world, where we're looking at building optimization, we're going to be looking at a lot of leveraging on automation and data to enable a learning cognitive AI system, where real-time adaptive control of operations can be fully automated. And with such, we're going to get clear ROI and operating efficiencies. So I've come to my end of my presentation. I'm going to hand over to Isaac to talk about some of the insights and trends that he sees in terms of from Fusionex perspective. Isaac?
Thank you. Good day, my name is Isaac, and I'm the VP for Products and Solutions in Fusionex International, a company that focuses on providing insights using IoT, big data, and data analytics. I'm going to talk a bit about analytics, IoT, and how its contribution is significant to smart buildings and smart cities. Well, one might think, amidst all the technological evolution around, why place focus on smart cities? Is it worth all the time, money, effort, and investment that it requires? Let's take a closer look at some facts. According to the World Health Organization, 60%, a staggering 60% of the entire world's population will be living in cities by the year 2030. That's less than 15 years from now. Why is this happening? Perhaps the question to ask is, why won't this happen? It has been in our human nature to strive and look for a better living environment. Now, this would include better infrastructure, better security, convenience, and cost efficiency. In essence, towards a better living condition and experience. Experience is the key word here. So with all these taking place, it's only natural that smarter cities creating a better living condition, a better living space, and experience is inevitable. Whether we like it or not, it will happen. More so ever, now that the technology required is matured and supports the fulfillment of such needs. Well, do we have the right hardware and technology today to create smarter cities? Cities that speak and interact with the human community and devices. Communication is the key here, and we have that in abundance. We have approximately 7 billion people today, and have 5 billion people that are connected to some type of network, some form, one way or the other. It is said by 2020, which is just 4 years down the road, just 4 years from now, we would have exceeded 30 billion devices. That's right around the corner. It's not a distant future. Now that implies that we are hyper-connected again. Microprocessors, which consist of all sorts of sensors from pressure to humidity, to wireless radio to heat sensors, etc., are here today. We can easily obtain a variety of these hardware and processing power at a cost so increasingly affordable. Now that's a lot of processing power in our hands to access everywhere and anywhere. Taking a step further, today we even have ingestible chips. These are chips which can be consumed orally to track heart rates, activity, rest patterns, and many others. Imagine you can now send data wirelessly via Bluetooth technology to your personal devices. Shocking, isn't it? This looks like it's extracted from a sci-fi movie, but these are real computing power and equipment that exist in our world today and already available to consumers. Cities that think, that's what governments are moving towards, replacing traditional buildings and infrastructure that used to be dumb and static. It's a race now to at least embark on a journey to build cities that can prompt, alert, and react to rectify problems proactively in an autonomous fashion. Some of the most common pillars of smart cities. These are what governments and organizations are racing towards. Now, it's normally a selection of handful of these pillars to start off with, then progressing with the rest in time. Smart environment for pollution control and climate adaptation, smart businesses with ICT integration for a smarter economy, smart living to encourage innovation and sustainable living, smart education to support better learnings for the new generation in preparation for a much more competitive world tomorrow. Smart citizens, where people within society are made more proactive to contribute as well as to enjoy community information. Smart government, where e-government would bring forth transparency and easy access to public sector processes. Smart infrastructure, where all, if not most, essential devices are connected and can alert and react accordingly. Smart utilities to reduce emissions, wastage, and optimize planning for resources. Smart mobility for more intelligent public and individual transportation, traffic control, safety features, and many more. So the question is, what are the essentials for a successful smart city or smart building? The answer lies in the next diagram, as you can see over here. It's best illustrated with some text on the board. Now, there is a lot of discussion about what are the most important elements to focus when building smart cities or smart buildings. And I would say top on the list would be security, efficiency, and most importantly, again, the experience. As humans are the ultimate users of these smart facilities, until and unless people are able to interact with these smart devices in a friendly and humanized way, initiatives like this will not take flight. It cannot be successful because people just won't use it. So how do we do this? How does IoT, big data analytics, help build smarter nations, smarter cities, and smarter manufacturing, for example? Let's take an example of what we Fusionex built together with Intel in smart manufacturing. As we know, production yield is key for manufacturing. Hence, downtime is a bad word for its industry. Millions of dollars are lost due to unplanned downtime. So undeniably, unforeseen downtime hurts production plants big time. So in the case of Intel, the use case is simple. How can we predict machine failure before it actually fails, of course? Fusionex Analytics Giant, which is our product, has the ability to connect practically to almost any data source. This includes transactional systems like Oracle, Microsoft, IBM, SAP, unstructured data sources like newsfeeds, videos, images, text files, social media, and even machines, sensors, IoT gateways to process fast and streaming data. As part of the initiative, Fusionex Analytics Giant connected to the machines within the Intel production plants to ingest machine-generated data. These are thousands of parameters per machine, which include heat, humidity, tremors, voltage, etc. Based on historical trends and downtime records, we built an analytical model to predict when the machine will fail when the same or similar trend occurs. These models detect and group data anomalies to conclude a result. For example, a sudden spike in humidity, a dip in voltage, a sudden drop of temperature. With the ability to process thousands of parameters and countless combinations, IoT applications can now predict with great precision when a machine is going to fail based on symptoms that has happened in the past. In this initiative, we managed to predict with an accuracy of close to 95%, right to the exact timing of when and which machine will suffer from downtime, saving millions of dollars in just a cluster of machines within the production line.
So Isaac, this is great. I mean, this is direct reference to how we can make anything smart, especially in a smart building. Mm-hmm. So one of the good examples I've seen was when I was actually at Columbia University was the CIO was trying to analyze how he can make his entire office building become smart, which is to, one of the projects he decided to take on was when does my phone fail? How often do they fail? So it's interesting that, you brought this example. I mean, not as complex as the example you just gave for Intel's manufacturing plant, but he was able to put information data that was collected from the IP phone, run into big data analytics, and then come back to the result that, hey, my phones tend to fail at a 5-year mark. So in that case, his predictive maintenance to ensure that, the customer experience, the user experience, as you had just mentioned, to be very smooth is, I'm going to start replacing phones at a 4.5-year mark, just so that I do not have to, have, my customers, my constituents coming to me saying that, hey, I need to fix my phone. Anytime the phone goes down, it's a big issue. So, I mean, this is a great example. And when you talk about the real-time streaming of data, how is that really important in terms of especially for smart buildings today? What are some of the things that we look at when we say, let's look at using Giant to do in order to create a smart building?
That's a good question. Traditionally, when we work with a lot of companies, they say that what they do with maintenance is most of the time they just schedule maintenance, let's say 6 months, 1 year, and in the case of the example, they say 4.5 years, for example. So that's not too bad. Nevertheless, there is some wastage as well, because sometimes you really don't have to perform the maintenance. And in some cases, even after you check or you replace, there might be another problem that comes up in year 4.5 or 4.8, for example. So moving forward, we move towards predictive maintenance to be very accurate in terms of which are the components that are going to be faulty, which one will be going down, and then you can hit the nail exactly on its head to replace these components. Adding to that, I think real time is extremely important. It's one of the most important criteria as well in smart cities, smart nations, smart manufacturing, simply because these alerts, if they are not on time, it would be meaningless. So, for example, if you're talking about security in smart homes and burglary, if you prompt the home user or if you prompt the owner 5 minutes late or even 2 minutes late, that could really define whether it's a success or failure, or whether people actually get out the house with a lot of valuable stuff. So I guess real-time analytics is extremely important in such initiatives.
So yeah, that's basically what I totally agree with you. Security is a major component in terms of key driver for real-time analytics and ensuring that building is a smart building. All right, so back to your presentation. Thank you.
Sure. So coming back to this use case, if you think about it, the use case is actually very compelling because each downtime can cost approximately 6 figures in terms of loss. But to replace a component proactively before it fails, it can only cost probably about $10. So that's an example of huge benefits and cost savings. So if we take a closer look at the reference architecture here, you will notice that having the ability to connect to the equipment, your data source origin, is really the first step to qualify for a smart initiative. Whether it's a serial port, RS-232, machine servers, IoT sensors, gateways, interface boxes, your solution must be able to connect and ingest the data from these machines. And that is what we did using Fusionex Analytics Giant. It has the ability to connect to pretty much any data source, any platform, format, size, and speed. Then transporting, filtration, distillation, and the necessary aggregation must now take place, which again, Giant is able to process, storing into Hadoop clusters or data warehouse, depending on the use and analysis of such data. If ETL and cleansing is required, scripting can be added on top before applying advanced analytical models to support the respective use case you are trying to look for. As part of the product, Giant comes with different templates, whether for manufacturing, security, or other industries, as to the jumpstart, but needless to say, all configurable and customizable to better suit business objectives. The primary value is seen at the analytics layer, where the business gets to benefit from predictive maintenance, reduce costs, improve quality, and many other models to expand from. Lastly, but very importantly, the visual layer will display the results in the most interactive way to users, and this comes in the form of line charts, bar charts, geographical maps, heat maps, pie charts, or even more sophisticated shape files, AutoCAD files, 3D, or custom widgets. We provide an SDK to custom develop your very own visual components.
So, Isaac, quick question. In terms of data management. We look at IoT solutions, especially in a smart building. We have different types of sensors, we have different types of devices. So what you're saying is that with Fusionex platform, it kind of helps aggregate all this different structured formats very, very quickly, which I have spoken to a lot of building managers is one of the biggest challenges. What's the typical time frame? What's the typical, length of time in order to actually aggregate and get this, extract out this information from all these different data sets? What are the steps involved?
Yeah, I think it's a very important question when you want to embark on such initiatives. It's also a very subjective one because depending on the size, the quality, and the state of the data itself, and the number of data sources. But I guess broadly speaking, normally we would try to provide some insights and aggregate the data, process data, and provide the intelligence as a pilot phase or phase one within 3 or 4 months.
Okay. So typically, how many data sources will you be looking at? So if I'm a building owner, do I start with the AC system, the air conditioning system, or do we start with just one system, or do we start with maybe 3 different systems to integrate? What would the typical recommendations be? Okay,
so this is primarily client driven. Many a times the client or prospect he's got a good idea in terms of what are the sources they want to start off with.
Got it. Okay.
But I would say that generally speaking, very few people do all at one go. In fact, I've probably never seen that happen before in phase one. But most of the time, you would start off with 2 or 3 data sources.
Okay, got it. Okay, all right. Back to your presentation. Thank you.
Yeah. So the next slide just shows you a different representation of Fusionex Analytics offerings, which covers the following layers. Integration with the various protocols, specifically for IoT, including Modbus, SNMP, TCP, CAN bus, ZigBee, and other industrial standards. Again, we are not limited to these connectors and can expand with justification across traditional data warehouses or data stores like Oracle, Microsoft, Excel files, etc. So that's really not a concern. The data store and management layer covers all the management of metadata, resource management, storage optimization methodologies using machine learning, stream processing, search engines, NLP, just to name a few. Again, the analytics layer comes ready with industrial templates and also covers a full spectrum of offerings, including alerts, monitoring, case management, workflow, the regular KPIs, data models, and security management, which are all very important components. All these are then rendered to HTML5, which will support any form factor, be it on your desktop, laptop, cable, or mobile devices, irrespective of whether it's running on Android, Windows, or iOS.
So basically, if I'm the building maintenance manager, I could be walking around with a tablet, being able to look at different insights that the system's coming out, the health of for lack of a better term, the health of the building, basically anywhere in the facility.
Yes, that's extremely important we see today because a lot of people work in a mobile fashion. They use their mobile phones more than they use the desktop or laptop, and that enables you to actually inspect and move around the building in a mobile fashion as well, just holding your mobile devices and monitoring and tracking.
Right. And you mentioned natural language processing, NLP, in the product. So how does that enable administrators to get intelligence from their smart buildings? I've seen that in action, but I think the audience will be interested in knowing what are the applications for NLP in terms of making a building smart.
NLP is extremely important today. Like I mentioned, experience is the key success criteria for such initiatives. And NLP is the most natural and humanized way to interact with these smart systems. It allows the users just to speak or just to type in commands to interact with these smart systems to find insights, get alerts, and action upon new findings.
Right. So basically, if I'm the building manager, I don't even need to know how to use like a real reporting tool, but be able to just ask in a natural way to the system, like Fusionex, and says, what is my peak consumption during today's 24-hour period, and the results will come out instead of having to actually go drag and drop look at data. Right.
I think we see an evolution where we're moving away from drag and drop, which is pretty intuitive, but when it comes to NLP, it's much, much more humanized because you don't have to learn the controls.
Right. So will you say that smart building with such smart technologies actually make the building operators a lot smarter too? it's a domino effect. It makes everybody a lot smarter.
I think so. I've come across many people who are concerned that they will be out of jobs because buildings are smarter, cities are smarter. But in reality, that won't happen. It just enables people to make smarter decisions, and you focus on making decisions and finding insights rather than crunching data.
Right, and you're making the right decisions, data-driven decisions.
Exactly. Very factual.
Got it. All right, back to your presentation. Thanks.
Sure. So this is how we take our clients typically on a journey through analytics, IoT, and smart implementations. You start off with a business transaction application, capturing data, and most organizations already have this in some form or the other, different formats. And then you build a BI data warehouse initiative to cater KPIs and internal systems monitoring. As time goes by, you find the organization's appetite for data increases and the need to process external data sources such as audio seems beneficial or at least potentially beneficial to providing further insights to the operations of businesses. This is where Fusionex analytics giant helps build a big data refinery, now capable of processing both structured and unstructured data sources, internal and external, to deliver unexpected results and insights not seen before. And ultimately, these will feed back to the transactional systems to provide recommendations and automation. So really, automation is the icing. So it's a cyclic initiative whereby you start off with core transactional applications, going all the way to data warehouses, which is not wasted if you have built such initiatives. Moving on to build big data refineries to provide you insights and as a feedback to the core transactional applications. So my last slide over here just illustrates that building automation is really the last mile to allow machine sensor systems to interact with one another to optimize processes and operations to deliver the best of quality and experience to the business or consumers. So as people are time poor and want to be efficient, people are looking for more rewarding and better experiences everywhere. Hence, the need for smarter buildings, smarter cities, smarter nations is inevitable. It will take organizations and countries a while to get there, but this is the race to nirvana. And the sooner you start, the sooner you pick up lessons along the way, improvise, and get there eventually. Good luck and all the best in your journey.
Thank you, Isaac. So I have a couple of quick questions for you too. From your perspective, you mentioned about smart buildings, smart cities, smart manufacturing. Analytics putting the smart in a lot of these initiatives. How tough is it to add the smartness into existing building infrastructure, whether it's the sensors or whether it's software? I think the software component is really great. I mean, what I saw from the slide is because we have so many different types of sensors and devices, there are a lot of unstructured data. And pretty much big data analytics is the only way to solve that. But how tough is the downstream the initiatives, adding the smartness to the devices? How do we, if I'm an existing building owner, how tough is it to add such smart sensors to it?
Sure. According to studies, close to about 60% of the smart cities and smart nations haven't been built. So in reality, cities have the opportunity to build from ground zero, implementing these smart devices, even actually before the actual realization of these cities today. But for existing cities, it's really not hard to find these devices. The key is to find the right partner. And I guess one of the problems that most people face, or challenges I would say, is that they try to implement everything with one vendor, and that's very difficult because either you're an expert in software, in analytics integration, or you're an expert in devices and hardware.
Right.
So it's really about finding the right partners, and these partners come in reality in abundance globally today. It's a very globalized nation. So finding the right supplier will enable us to find the right devices. It's not a major challenge.
Got it. So, and from your perspective, because you have a lot of experience working with our customers, both for smart building and smart cities, a lot of data is being produced by these smart building sensors. In your opinion, is it a cloud solution a more viable solution, or is it an on-premise solution that's a more viable solution? Or do you look at it as maybe it's going to be more of a hybrid model? What, in your opinion, what do you see the trends in implementation?
I think in future it would be largely cloud. Today itself we see a lot of hybrid solutions. People still have concerns about data being on the cloud. So normally they would segregate out some to be on the cloud and some to be on premise. That's the trend that we see today. But for quick initiatives
assuming we're done with our presentation, we're going to move into our Q&A session. So let's start with the Q&A. Let's look at what we have that has been sent into the system.
Hi, everyone. This is Tri speaking again. We're here to talk about the several questions and answers that has came into the webinar. So if you have more questions, keep them coming. We'll answer them in the next 10 minutes. So one of the first questions that we received was from Prakash from Smartron. His question was, does Intel Joe support Linux? Yes, it does. In fact, it supports various versions of distribution of Linux, and Microsoft also just recently announced that the Intel Joe will actually support Windows 10 IoT Core before the end of the year. Right. So quick questions. So several questions that we have here. Isaac, do we have you back online?
Yes.
Right. So one of the questions we have here is how can owners or landlord of old buildings, typically those over 15 years, make their buildings smart, and where and how should they start?
Well, there are many ways on how they can do it. I guess you don't always have to build a building from ground zero all the way up. If you have an opportunity to do that, I think that's okay. But if not, then there's always baby steps that you can take. So one can start by installing smart meters. We see a lot of the old buildings starting with some smart meters, whether it's utilities, whether it's electricity or gas, that's possible. And the other area that we see a lot of building managers or developers try to enhance their buildings to be smart buildings would be in the area of building management systems and smart applications. Smart apps you can build very easily on mobile devices, so complemented with some economical sensors to enable smart car parks, smart lightings, smart concierge, and smart security services. That would be probably the easiest way to get a footing for smart buildings.
Thank you. Good point. We do have several questions coming in. So they ask, how often do owners and landlords, have to take into technical considerations, for example, the IT infrastructure or Wi-Fi, near-field communications, in terms of making their building smart when going on this initiative? Actually, there's several questions that pertain to security. In terms, I'm thinking there are questions around the way the data is encrypted or how data is being secured after you have curated. What's your opinion on this, Isaac?
Well, more and more we see a lot of owners and landlords and developers taking these into considerations. They understand to provide that technological advantage, that extra premium service you need to enhance the buildings to be smarter, to be able to interact within themselves. So yes, they do take into consideration IT infrastructure, Wi-Fi, NFC, etc. But every once in a while, you will still come across some of the building managers and property developers, landlords who are old school, and hence they find that they just want to keep things low in terms of economy and not raise the prices too high in any form or fashion. So that happens once in a while, but more and more we see a lot of people taking into consideration investments into sensors, into smart devices, IoT solutions.
Got it. So the next question I have, which is how smart buildings are cost efficient. I'm going to kind of rephrase that to help the audience with that is. So I would say the question would be, what do you think would have the highest impact in terms of the ability to lower costs in a smart building, in the sense, being really cost efficient? What do you think is the first area that a landlord or a building owner should tackle?
I guess it really doesn't have to be very expensive today, because in reality, without mentioning specific brands, there are a lot of such smart devices, sensors out there in the market which you can tap upon.
especially if you buy in bulk, that's even going to be more economical. The areas where we see the highest impact would naturally be security. It's easy to get the buy-in of consumers. It's easy to get in the buy-in of sponsors, developers, etc. when they talk about security and safety, because that's constantly a priority. So focus on that would probably be a very good first step. Complemented with smart apps, mobile applications, which is very, very rampant today. So people invest in all kinds of smart apps, and that's not very hard to do as well. So providing smart app solutions, which can be rapidly developed, coupled with sensors that focuses on security and safety, I think that's where the first step should be.
Thank you, Isaac. In your opinion, looking at Asia Pacific in general, what do you think of the maturity and readiness of each country ready to adopt these features and functions of smart buildings? Do you think most of the countries and organizations are ready, or there are some countries and organizations that are ahead of their peers?
Well, I guess in Asia Pacific, in reality, in terms of competency, skill sets, whether it's in technology, I think we are ready. We've got mobility today. We've got cloud for storage. We've got sensors. We've got analytic solutions. So I guess competency is definitely there. Where we probably lack is in the area of maturity, or some parties who don't realize that the technology is here to stay, and that's going to be disruptive to the market, and hence the need to move on is prevalent. So I guess maturity is probably the major stumbling block here, but apart from that, technology and competency and devices, we are ready.
Thank you, Isaac. The next question I have has relation to do with telco. So the question is, what is the role of telco for smart buildings? And will smart buildings primarily use fixed line for data collection in terms of data analytics, or would it probably be wireless? So my take on this is telco definitely has a role, especially if we're talking about both cloud solutions and also even hybrid solutions, because how else are the devices going to be able to connect to the cloud or to a central server in terms to do centralized analytics, even though we're seeing a lot of trend towards edge processing. And I think pretty much even with fixed line, there is a purpose for it, because sometimes you do have to fail over for the fixed line connectivity. You can't just depend on whether it's just Wi-Fi or wireless connection. What about you, Isaac? What's your take on telco's role in terms of smart buildings, how they support analytics such as, for example, Fusionex analytics solution?
My view is that telcos play a very pivotal role in smart buildings, smart cities. They form the backbone infrastructure of all these buildings and cities, so that's very important nationwide. Not just from one or two clusters perspective. And they realize that, they're beginning to realize that they have a very important role to play, and there's a lot which they can contribute. Hence, many of them are venturing out to provide value-added services, value-added offerings, applications, smart applications, to complement their current offerings. I guess whether it's wired or whether it's wireless, at the end of the day, there is a difference to consumers in terms of convenience. Most end consumers would prefer something that is wireless. So that's definitely where we are aiming towards, and we'll get there someday. As of now, I guess having it wired is not such a bad idea, as long as it provides the experience, the speed and performance that people are looking for. But apart from that, I guess wireless will definitely be the future, and that is where everyone is heading towards, where you will obtain full capability of wireless technologies and able to conveniently control different devices, able to interact without having the messy wires all around.
Right, especially I would say devices to devices communications, or even buildings to buildings communication, right?
Absolutely, yes.
Right. So I have a bunch of questions coming in, and they all surround around security. So I'm going to assume the questions pertains to data security. So from your perspective, once the data is already collected, let's say it's running on the big data platform of Fusionex, it's already encrypted. So that's pretty secure in my opinion. But so what's your opinion in terms of, do we encrypt all the data that's being encrypted during the point of collection, or do we not encrypt? Should we be more selective? Because when we encrypt data at the point of collection, it does add to the bandwidth, doesn't it? And then some data are just irrelevant in terms of whether we need to encrypt them, or should we really encrypt all of them? What's your opinion?
I guess there's always a compromise when you encrypt, and there's that extra processing and decryption that is likely to happen. So I've never seen any implementations where they encrypt everything, although I wouldn't say that that's not possible. If you wanted to do that, you could, but realistically, most people don't, and there isn't a real need to encrypt everything as well. So I guess as part of the implementation initiative, what's very, very important most of the time is to sit down and understand from a data security perspective, security protocols and such policies. It's important to identify what kind of data gets to be stored on the cloud, on premise, what needs to be encrypted, and what needs to be hashed out. So that's a very important discussion. Most of the time, it's one of the most important and primary discussions that people have surrounding smart cities, smart nations, smart buildings initiatives. It's one of the key topics.
Right. So you typically mention smart cities and smart buildings along the same line. What are some of the most interesting examples that you have seen or have experience with? Can you just give a quick example?
Yeah. Well, we have seen a lot of different smart cities and smart buildings around. The one that comes immediately to mind is this building that we've seen in Amsterdam. It's a commercial office building, and they've got about all sorts of different types of smart devices. That includes solar panels, that includes IP power over Ethernet, automatic ventilation. They've got about, I think, 30,000 or 40,000 sensors all around the building. That covers from energy monitoring to smart meters to dashboards for building management to almost operate and monitor all types of sensors and devices, all types of KPIs. So lighting, everything is controlled via smart applications, and it's automated as well, depending on the ambience, depending on the heating preferences, etc. So that's one which we have seen in Amsterdam. The other one which we have seen in Malaysia as well, we have seen a hotel where it's immensely smart, where you have doors which you can just open using your telephones, your mobile phones. There are also heating sensors, there are air conditioning sensors that are actually engraved inside the buildings themselves, although that's not seen to the general public. Apart from that, in terms of check-in processes, check-out processes, in terms of customer data, etc., there's a lot of information and sensors that's being stored just to help out in the overall experience. So more and more we come across office buildings, come across hotels, come across a lot of different industries where they want to ensure that buildings are smarter. It provides more alerts, it provides more prompts to people and the key thing is something which you can action upon. So what's really key is that anything that we work towards is something which the management or the building management can act upon.
Right. Good point. So in your opinion, I mean, you and I, we're pretty familiar with analytics, but in the space of analytics in smart buildings, I would still say it's pretty much still in the infancy, right? There's still a lot of education that needs to happen, educating landlords and also building owners in terms of what analytics can actually make their buildings smart. Do you agree with that, or do you think that it's actually pretty mature in the sense that most building owners know what it is about?
No, actually, that statement is so true. In reality, we see a lot of building owners, landlords, property developers. A good majority of them are well-established personnel. They're individuals and they're good companies who own a lot of these properties. And many of the senior execs would be very high-level or high-ranking officers who are in their 40s, 50s, sometimes 60s, 70s as well. So they need a crash course in terms of data analytics. They need a crash course in terms of IOT, smart buildings, etc. And it takes a while to educate and create that awareness, or more or less create that threat, so that they understand that this is here to stay, and it will be a level ground where people will compete against. But once you've got that underway and you've been able to create that awareness, create that threat, and more or less the opportunity as well, that's where you can see the sponsorship happens. That's where you get the buy-in and the funding for such initiatives.
Excellent, excellent. Thank you, Isaac. Really appreciate you coming on board for this webinar. We've reached the end of our session. So thank you, everyone, for attending this webinar. Thank you, Intel, for hosting us. And most importantly, thank you, Isaac, for providing us with really, really good insights, real-world examples. So we'll see everyone in the next webinar. Thank you for attending. Goodbye.
Thank you. Bye.